Good morning once again, Algebra 2 students. So in this lesson, we're going to be talking about the SOHCAHTOA in the right triangle trigonometry. So remember again, our focus is SOHCAHTOA, which means that sine is opposite OH over hypotenuse. Cosine is adjacent, which is lying next to over hypotenuse. And tangent is TOA, opposite over adjacent. We also have learned that in any right triangle, Pythagorean theorem holds. So a squared plus b squared equals c squared, or leg squared plus leg squared is equal to the hypotenuse squared. We've talked about some famous Pythagorean triples, 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. These are triples that hold true for the Pythagorean theorem and are whole numbers. So getting started on this triangle, we have a right triangle. We have legs of 3 and 4. I could, if I wanted to, using Pythagorean theorem, I'd say 3 squared plus 4 squared is equal to c, little c squared. So 9 plus 16 would be c squared. C squared would be 25. And c then would be 5. But that is a 3, 4, 5 triangle. Then, in finding the trig ratios for angle A, I'd focus on this angle. Sine is going to be the opposite, which is 4, over the hypotenuse, which is 5. Cosine then is the adjacent, that's the one lying next to, which would be the 3. So that'd be 3 over 5. And then tangent is opposite, which is 4, over the adjacent, which is 3. Then to find the angle, I could use any of those values, and I'm going to use the inverse, second sine of 4 over 5. I get that angle to be about 53.1 degrees. Make sure you're in degree mode. Then using the other angle B, sine of B is the opposite side, which is 3, over the hypotenuse, which is 5. Cosine is the adjacent, which is the one next to it, which is 4, over the hypotenuse, which is 5. And then tangent of B is opposite over adjacent, which would be 3/4. To find angle B, again, I could do the sine inverse of 3/5. Or I could take 90 minus 53.1, which would be 36.9 degrees. Our next triangle here is a 5 something 13, 13 being the hypotenuse. I recognize that to be a 5, 12, 13. Otherwise, I could have went 5 squared plus x squared is 13 squared. So 25 plus x squared is 169. Subtract that 25, and x would be 12. And then focusing on angle A. Angle A, opposite's 12. Hypotenuse is 13, so that's the sine, or the SO. Cosine's ka, adjacent over hypotenuse, 5 over 13. And TOA is tangent, opposite over adjacent, which would be 12 over 5. To find that angle A, I could do the sine inverse of 12/13. I could do cosine inverse of 5/13, tan inverse of 12/5. They're all going to work. And I should get an angle of about 67.4 degrees. Then using angle B, sine of B, opposite over hypotenuse. Cosine of B, adjacent over hypotenuse, would be 12 over 13. Tangent of B is opposite over the adjacent, which would be 5/12. To find that angle, I'm going to do the sine inverse of 5/13, or take 90 minus that other angle, which is going to give me 22.6 degrees. Next one's 8/15. I recognize that to be 17, otherwise you could use Pythagorean theorem again. Sine of A, focus on the angle A. Opposite's 15. Hypotenuse is 17. Cot 8 over 17. Tangent of A, opposite over adjacent, which would be 15/8. And then again, I could do any of these inverses. I'm going to do tan inverses this time of 15/8. Make sure you're in calculator degree mode. And I get 61.9 degrees. So I know for sure this angle B must be 28.1, 90 minus that. Sine of B, opposite over hypotenuse, 8 over 17. Cosine of B, adjacent, next to, which would be 15 over the hypotenuse of 17. TOA is opposite over adjacent, which would be 8 over 15. And then the last one, this is 4, a leg of 4 and 10. That's not a Pythagorean triple. Pythagorean theorem, 4 squared plus 10 squared would equal c squared. That's 16 plus 100, which is 116. So c would be the square root of 116. That would be my hypotenuse. And I'm just going to leave it as a square root. It's going to be 10 point something. Let's just leave it like that. Sine of A, angle A, opposite of A is 10. So it's 10 over the hypotenuse, which is the square root of 116. Cosine of A, adjacent, next to 4 over the square root of 116. And tangent of A is opposite over the adjacent, which is 10/4. I do tan inverse of 10/4, an angle of about 68.2 degrees, which makes this one 21.8. Got to add up to be 90. Sine of B, here's angle B. Opposite of that is 4. Adjacent is, again, square root of 116. Cosine of B, adjacent's 10, so it's 10 over the square root of 116. And tangent of B, opposite over adjacent, 4 over 10.